Welcome to my presentation. This presentation is part of the playlist Indefinite Integrals More Examples. In this presentation, we will be solving examples related to exponential and radical functions. Let's look at an example. Let's evaluate this indefinite integral y squared square root of y dy. So the way to solve this one is we need to first convert the radical terms into exponential terms to be able to use the process of integration or apply the process of integration. The way to do that is as follows. We're going to take the square root of y term and then write it out as follows. We can write square root of y as equal to y to the power of 1/2. That is one of the rules of converting the radical terms into exponential terms. Once we have that in place, then we can write the given function as integral y squared times y to the power of half dy. According to the exponential rules, if the bases are the same, we can combine the powers. So using that rule, we can write this one as y to the power of 2 times y to the power of half. We can combine, since the bases are the same, we can combine the powers. So we can write the base once and then we can add the powers 2 plus 1/2. So y to the power of 2 plus 1/2. 2 plus 1/2 is equal to 5 over 2. So we can write the given function as integral y to the power of 5 over 2 dy. Now, since we have simplified the given problem or the given example problem, we can now apply the integration process to simplify it and then arrive at the answer. So integrating this function, we are going to integrate y to the power of 5 over 2 dy. So we can write this as y to the power of 5 over 2 plus 1 divided by 5 over 2 plus 1 plus the c is the constant of integration. Whenever we integrate something, we're going to add a constant of integration like that. In here, we are using the letter c. So 5 over 2 plus 1 equals to 7 over 2. So y to the power of 5 over 2 plus 1 converts to y to the power of 7 over 2. And in the denominator, we have 5 over 2 plus 1. That simplifies to 7 over 2 plus c. So when we simplify it some more, in the denominator, we have 7 over 2. And when we bring it to the side of the expression, it converts to 2 over 7 times y to the power of 7 over 2 plus c, where c is the constant of integration. And that is our solution. So this is the way we want to be able to solve exponential problems. Let's look at another example. In this example, we have exponents and radicals combined. Let us evaluate this indefinite integral negative 7 divided by cube root of x squared dx. So we can write this as y equals to integral negative 7 cube root of x squared dx. We need to convert the radical terms to exponential terms to be able to apply the integration process. So what is it we need to simplify here? The radical term is cube root of x squared. Cube root of x squared we can write as x squared is inside the radical term, and since this is the cube root of that, the way to convert a radical term to an exponential term is as follows. The inside term remains as is, and the radical term, the cube root, converts to 1 over 3, like that. So we have x squared, the whole thing raised to the power of 1 over 3. So here again, we are going to use the exponential rules. And one of the exponential rules is telling us that if we have a power and that is raised to another power, we're going to multiply the powers. So the base is x, and the powers are 2 times 1 over 3, which is 2 over 3. So the radical term, cube root of x squared, can be written as an exponential term as x to the power of 2 over 3. So we have rewritten the given function. We can rewrite the given function as follows. y is equal to integral -7 divided by x to the power of 2 over 3 dx. Now, since -7 is a constant, we're going to take it outside of the integration process and write it out as y equals to -7 integral 1 over x to the power of 2 over 3 dx, like that. Now we can simplify it some more. Y is equal to -7 integral. We can bring this denominator to the numerator, and when we bring it to the numerator, the base, the term we can write as x to the power of -2 over 3, like that. When we have a term in the denominator with a positive exponent, when it comes to the numerator, it becomes a negative sign. It converts to a negative sign. So the given expression becomes y is equal to -7 integral x to the power of -2 over 3 dx. Now we are ready to apply the integration process. When we do that, this is how it's going to convert. -7 remains the same. It's a constant. Integral x to the power of -2 over 3 dx converts to x to the power of -2 over 3 plus 1 divided by -2 over 3 plus 1 plus c. We are using the power rule here. So therefore, when we simplify it some more, -7 times x to the power of -2 over 3 plus 1, when we simplify that, it becomes x to the power of 1 over 3, and the denominator we have -2 over 3 plus 1. When we simplify that, that simplifies to 1 over 3, and then we going to add the constant of integration c. Now, when we simplify it some more, -7 times, in the denominator we have 1 over 3, and that converts to 3 over 1 on this side of the expression. And then we have in the numerator x to the power of 1 over 3, and then we're going to add the constant of integration plus c. When we simplify it some more, we have -7 times 3 is -21 times x to the power of 1 over 3 plus c, where c is the constant of integration. This is how we're going to solve this indefinite integrals when we have radical terms and or exponential terms involved in the given example problems. In my next video presentation, we will be solving more examples related to indefinite integrals.